Hello, my name is Craig Otto. Today we're going to talk about a lean manufacturing tool called Just-in-Time. This is actually one of the pillars of lean. Basically, the other pillar is to respect the individuals. This pillar is very significant though because it is all about inventory reduction, and that's really what Just-in-Time is about. Ideally, Just-in-Time, what that means is you have one piece flow, which means that you make one and you move one. It assumes that if you think of kind of like an assembly line, everything has equal cycle times and it all moves at the same time. A lot of it is very lean, meaning it's close in proximity and processes because you've eliminated the waste of waiting and transportation. The processes should be very stable, shouldn't have a lot of quality issues or things like that. And then, of course, minimal changeover time as required. Now, everything is not as perfect as this. When you don't have stable processes, you may have to have what are called buffers, but you can still do a pull with just-in-time, but it's just you have these controlled buffers, these controlled amounts of inventory. Just-in-time does not mean that it's zero inventory. It just means that you have the right amount of inventory for your process, that you're able to keep it consistently flowing. Okay. So again, just-in-time, it's the way you manufacture most economically. In other words, you produce what is needed, when it's needed, in just the right amount that's needed with the minimum amount of resources. And that's really what just-in-time is all about. Looking at it from an overall standpoint, there's kind of components of just-in-time. First of all, you have to have a level schedule of production. Anytime there's a major fluctuations, that's going to cause some problems with the just-in-time process. But basically, what you're trying to do is minimize the inventory. And to do that, you have to have a continuous flow process. You have to have what's called a pull system, and then also takt time. Okay? And first, we're going to talk about the continuous flow process. So here we have an example of two different processes. One is called batch and queue, and then the other is called continuous flow. And basically, in the batch and queue method, you have stations A, B, and C. At each station, there's a different type of process, and basically, one process builds on the next. So in station A, it's called batch and queue because Station A creates a queue. They build so many, like say they build up 10, and then they ship it. And then you can see the little forklift transportation there to Station B. And then Station B builds up like 10. And then they ship theirs with the forklift to Station C. And then Station C builds theirs up. That's called batch and queue. And what we really want to do with the lean process is get away from that. We want to go to more continuous flow. So set the work cells up where A, B, and C are in a work cell right next to each other, so you eliminate that transportation. And the other thing that it does is it reduces the inventory required because they produce it one by one. Produce one, move it to the next station, produce one, move it to the next station, so forth. Ideally, you have no inventory where flow never stops. That's an example of a refinery there. You're constantly producing product versus the assembly line. That's more likely what you'll see where you have minimal inventory, and as one item's finished, the other one starts through the same process, and it just increments down the line. The second part of just-in-time is this thing called pull systems, or Kanban. We'll get into Kanban here. But before we do that, let's take a look at pull systems. Basically, you start at the top where it says sales. In other words, there's a customer need for it. You never want to produce something that there's no need for, and that's waste. So you have to have a need, so you have sales, and then that drives your production control, and then they basically level the schedule out. And then that goes back into where your raw materials and some of your supplier processes, those all start feeding maybe what's called a store where you hold these parts for the line. And then the line, you can see they have Hijunka, which is sequential flow. and it's also balanced by whatever type of product you need, so that you have that pull signal there, and then you basically run it down the line, one piece flow. And there's certain places where maybe you need inventory buffers. That's all part of it. And basically, as it flows down the line, it's all driven from that sales. So you can see how it pulls. The end of the line basically goes to the sale, so that creates a pull for the one before it, and then it drives all the way back through the system. Okay. And I mentioned Kanban. That's just a type of pull system, or it's a signal basically. And again, there's prerequisites for Kanban. You can't do this unless you've done some of the other things like 5S and Visual Factory and standard work. Those are all prereqs to being able to use this Kanban technique appropriately. I mentioned it's a signal. There's two types of signals. Basically, it's Kanban, again, before I get into that, means visual or card. It's something that the Japanese created. And what the signal or card could be is a license to make a product and or a license to take a product. So there's a production Kanban or a withdrawal Kanban. So two different types. And whenever there's a signal like that, that's how you know to either make something or take something. Supermarkets are a good example of that, where obviously people take the cereal, and when it runs out, that creates a pool. And from a manufacturing standpoint, that was converted. Actually, we learned from the supermarkets, converted that over to the manufacturing realm, and you can kind of see, again, it's gravity fed to reduce motion, so that you don't have to push parts to the front. All gravity fed, pull it, and then whenever it runs out, you can pull the next set of bins. They also have what are called two bin systems. I don't have an example there, but basically the operator will they'll have two bins, one bin and then one behind it. So as soon as the first bin is used up, the operator put that bin up top, signaling that that particular part needs to be replenished. And then he has that second bin there to use if he needs parts for the next for the next cycle. So that is examples of just-in-time. This is actually a two-part series. This is the first part that I shared with you today, and look forward to the next video where we're going to finish up talking about just-in-time.